It's basically an overview, and I'm going to show you, I think, the latest and greatest additions that we've put into the software. Before I get into the explanation, I just want to say we've been saying that it's a fast forward button ever since we first started talking about this, before we even introduced the alpha of the software. And I think we even had this recorded in a next dev presentation from almost 3 years ago at this point, that we called this a fast forward button, that it's a fast forward button for a team using BIM. So while we do focus on the early part of the project, the reason that Schema is useful is that it takes fully fleshed out BIM arrangements from your current projects and past projects and allows you to easily reuse those. And I'll show you how that happens. But the idea behind this is we're a fast forward button. We're not really intended as a collaboration platform. You get into Schema, you fast forward your project, you take the results of that and you put it wherever you want. And we've evolved that idea, and I'll talk about that. So very basically, just to get into it, Schema is web-based software. So there's nothing to install, runs in a web browser. It's sort of table stakes for all of the new design apps that are coming out that either have AI incorporated them or just are doing design in a browser, right? So it's web-based software. It has a data-driven workflow. So there are no files or file formats. You're doing live data all the time. It has live updates. It's multi-user. It has all the things that you would expect from modern software on the web. It's easy to learn and use. It has web services integration out of the box. This is what we're calling the Swiss Army knife idea. We're not intending Schema to be a platform. It's more like we're intending it to be a Swiss Army knife that understands how to connect things together. And we'll talk about that also. Another thing to know about us is that we have no technical dependencies on any major vendor. We're not written on top of, say, Forge or Autodesk APS or any other vendor's tech stack. We've written this whole entire tech stack that we've been demoing for the last couple of years, so that we don't have any, there's nobody's ability to turn off the components that we're using if they don't like what we're doing. And this idea of Schema as being embeddable as an extension, which takes the Swiss Army knife idea and extends it to be what we call the tool chain idea, which is borrowed from movies and gaming industries, where they're constantly building these tool chains for new projects where they have ad hoc teams that are used to using different tools working together. So I'll get into what Schema isn't in a minute, but I want to tell you the big idea that it starts with, and it's based on this a sketch in a book called Refabricating Architecture from 25 years ago, around the time Revit got started. This idea is also the basis for prefab in delivering the building. But what we've done with Schema is tried to make a design equivalent of it. If you look at the top diagram, when people spend 8 hours a day or whatever picking points in a BIM tool like Revit, you might be picking those points, creating walls, doors, and windows. Revit's creating objects. The objects are storing metadata. They're capturing what the relationships of one object is to another. It's building a big web of objects as you pick points. Schema doesn't work that way. What Schema does is it takes the result of a BIM platform and it looks at past projects to say, oh, these are interesting assemblies or whole layouts that are reusable in this project type. And it builds a catalog of those in a way that makes those easily reusable so that you don't have to start from scratch on the next project. And that's really the big idea. It allows you to work with whole chunks of the building as opposed to individual data entry for walls, doors, windows as what you're doing. And so when we first came out with this a couple of years ago, the idea was we called it the first BIM knowledge reuse engine because it really ingested the BIM data from a team that had used BIM for years, and many architects had 10, 15 years worth of this data sitting on file servers. And we've evolved this idea, but the idea when we explained this was there's really two sides to Schema's technology. One is this Schema AI side, where it's an easy to use, sketching in a web browser with some simulation, and this really easy to use block and stack with this special feature called morphing in order to be able to take the things we harvest from previous projects and make them sort of infinitely flexible puzzle pieces. But that the building itself, solving the partie, is this blocking and stacking exercise with these 3D puzzle pieces and with the generators in order to help you come up with the solution that meets the program requirements as easily as possible. With the result of that then being able to generate some high quality BIM data straight out of the software in a minute to a minute and a half, as opposed to 6 or 8 weeks. And so that was the idea, is that it's schematic to BIM in minutes, not months, and that it's not a throwaway conceptual feasibility tool where you then have to remodel everything in a BIM tool like Revit. Rather, we take the BIM you already have, productize that. That allows us to produce the complete BIM output. And because the BIM that you feed into it has your office standards already embedded into them, the models that Schema produces already have those office standards and best practices embedded in the output. And so that is, I think, pretty important about the way our system works. It's meant to produce native Revit objects out of the box for anything that you can produce inside Schema. The mechanism by which we enable that is to look through the projects. We then build up an analytical model of what we see. As we get more and more data from more and more architects, we're using computer vision techniques in AI to recognize the relationships between these things. And then we take that analytical model, database that up in the Schema cloud, and we associate a whole bunch of binary Revit objects to that layout, so that when we morph and stretch and change the shape and size of that layout for a future project, the Revit objects know how to follow that and update, so that you work with things at a high level of abstraction, but then we can produce a high level of detail without having to do any additional work when you produce the BIM model. So we're just going to show you real quickly this big idea at work. So you take a bunch of stuff in Revit. Typically, we've just organized these as groups because people have used groups in Revit to kind of represent these sorts of assemblies. I'm showing you the classic apartment building layouts as the things that we make up for our catalog in this case. And then we have a generator that allows someone doing a design to lay those out really quickly. And then we have morphing that allows you to then make them unique to the project and produce something new out of the starting point you got from data in a past project. It's not that we want you to do cookie cutter things that all look the same. It's that we just want to take the time out from having to start from scratch, but allow you to use those things in a flexible way. And then, we don't have to solve everything in Schema. We don't expect you to do 100% of the design in Schema. We expect to be able to produce 60 to 70% of the scope of the project, and then you might be doing the last 30 in a BIM tool. Here, we're doing the morphing. We're taking these units and we're turning them into more trapezoidal shapes so that we have a different facade. We're doing this to get some interesting looks on the outside of the building. And then we're going to use that and directly generate the Revit data from it, because we have this principle that everything in Schema will produce well-structured native Revit data out of this. And this is part of the fact that we have some of the folks on the team that helped create Revit to understand some of these structures internally and how to produce this data well. And so that's the main, that's the main output, is to fast forward this process and save up to 2 months of work to get to a point where you could produce some deliverables so that the firm can get paid. This is an example. We've shown this example a lot of some output from Schema. In this case, this is, again, a residential example, but we've done this with hospitality, with schools, with data centers, medical, retail. There's a number of different project types that use this sort of horizontal workflow to achieve the models for their particular building type by just using this content strategy of generating a catalog from previous projects. In this particular example, the podium here was hand modeled in Revit, and then the blocks above with all of the room layouts were done in Schema, and then the models were combined. So, you don't have to do everything in Schema, like I said. You can mix, match, and choose depending on what approach suits the project team the best. So the idea then with this implementation is that designers can then experiment with whole chunks of the building instead of individual layouts, and that you can test things by using generators, and we keep improving and covering more use cases with the layout generators that we have. We just showed something to we have a group called the Pioneer customers that see things before we release them. We just showed them what we call the puzzle piece solver, where sometimes we find that there are units designed to have adjoining edges with other units for different purposes. And so now we're including those in the solvers. I'll talk a little bit more about how you'll be able to write your own solvers and include them in our solver pipeline so you can inject your own logic into what we're doing. But this idea of experimenting with the whole chunks of the building and turning that into a building and using this block and stack as a key capability in a tool chain is what we're calling this capability a Swiss Army knife, because this is something that every designer has to do on a project. You have to come up with the partie. And so even though we've laid this out where there's a conceptual side of Schema and then this ability to generate the high LOD BIM, we've now gone and integrated not just our own conceptual tools, but integrated tools people use every day like SketchUp and Rhino, with this idea of Schema being a Swiss Army knife that knows how to ingest that and apply this blocking and stacking process to it, so that you can then use that to generate the Revit data from it. So those are some pretty interesting examples. Those are some of the latest things that we've added into this. We demonstrated the SketchUp functionality at Trimble's worldwide conference back in November. We have just literally shown the Rhino functionality to our Pioneer customers a couple of weeks ago. So let me just give you a quick demo of those. Again, starting with the catalog functionality, we take pieces out of Revit to turn them into a catalog. When that catalog's in Schema, it's a simplified version that looks like this. But now, instead of starting the project in Schema, we're actually starting it in SketchUp Desktop. So in this case, we're massing up a building in SketchUp Desktop, and then we launch Schema as a extension in SketchUp. And what we can do with this extension is we can mirror data back and forth between SketchUp and Schema. And then in Schema, we can go through the normal blocking and stacking process. Now, in this example, what I've done is we've done it double time, but we haven't cut out any of the steps. So in real time, this rationalization of the floor plate takes about 4 minutes. In this demo, we double speeded it, so it's going to take about 2 minutes. But this is essentially the process you go to rationalize a floor plate in this type of building in Schema. So we're figuring out the elevator core. We're not actually going to lay out the core. We'll do that later in our BIM tool. And now at the end, we have this angled end wall condition, and we don't have units that match that. So we're just going to mass in some shapes and then use the morphing to create some units that'll fit that. We're also going to put another stair core out here. And again, we'll resolve that in the BIM system later. And now you see the morphing creating the units on the end there. And now that's the floor plate that will apply to all the floors of the building so that we get that side. We then run a generator on the other side. And here's our preliminary layout for our project. Now we'll take this using, again, that extension methodology and mirror LOD 200 versions of the units into SketchUp. Because now in SketchUp, we can do things that SketchUp has, like diffusion rendering inside, and start getting some feedback from the client about what, facade ideas we might want to use. In this case, client gives us some feedback, says, the top of that building has good views. I want to improve the revenue generation. Could you redesign the top and use some more premium units and maybe change the materials? And now when we do that change inside Schema, what we'll do is instead of generating the LOD 200, we'll generate the LOD 350, so that we see the actual walls, doors, windows, and all the furniture, fixtures, and equipment that generates. And now we'll synchronize that into SketchUp. And the reason for this is that we actually designed this workflow around an actual customer of ours in Atlanta, TVS Design, where they actually then go and do the conceptual curtain wall design in SketchUp. That was this principal's preferred workflow, was actually to do the curtain wall preliminaries in SketchUp. So in this case, we're doing the building assembly from its component parts in Schema, mirroring that into SketchUp, doing the curtain wall in SketchUp, and then mirroring the curtain wall into Schema. And then again, because of the rule that everything that we can have in Schema produces native Revit objects, you can see then the full fidelity data as native Revit objects. If you cut a floor plan, you'll see exactly what you would expect to see from a Revit model and a floor plan, and you're ready to document this or take any of the other sort of documentation automation tools that Revit has and apply them to the output of this process. So there's sort of the tool chain and the Swiss Army knife idea applied to SketchUp. It's pretty similar applying it to Rhino. In this case, we're going to use Schema as a Rhino extension. So we've got Rhino desktop now on the right, Schema on the left. And we're going to take our project environment and actually first mirror that into Rhino with the terrain and the surrounding buildings. And then one of the things that this allows is, survey data in Rhino, because Rhino has all of the typical kind of AutoCAD drawing functionality mirrored into it. The ability to take those things, get site and surveys, and use those and mirror those back into Schema. So again, we have a two-way live synchronization between Rhino and Schema. If we have a site that we've created or brought in a DWG for or DXF or PDF or whatever we want in Rhino, we can then take that and use that as our construction site in Schema. We can do mesh edits on the site and mirror those into Schema if we make those edits in Rhino. In this case, we have a massing for an actual building in New York in Rhino, and now we've mirrored that into Schema. And then just like I showed you on the SketchUp example, you can take all the blocking and stacking tools with that as your starting mass and use all the generators and do the layout for this particular building in New York. So this is the idea behind Schema, the fact that it's a very useful best-in-class block and stack that allows you to reuse your BIM data, and now not just having to do it in our web app, but being able to start the project in whatever your favorite tool is and use us as a mediator between those tools and a BIM system like Revit. You can get some pretty significant project outcomes. So first off, every architect who uploads our data to us, their data is confidential. We don't share any of the data between the architects. We don't train an AI on them. So when we do any sort of computer vision techniques to go and build the catalog, those AIs are pre-trained on generic data in order to do the recognition. We're not training any of our stuff on the data that we're getting from our customers. That's a pretty big deal these days. Because of the copyright implications, right? The next is significant project time savings. So we've had teams that are saving 6 to 8 weeks because they don't have to go and take a whole team to build the Revit model. We do it in a minute and a half. Increase in design quality, increase in project profitability, potentially. Some significant potential to decrease documentation errors because of the consistency this affords. The ability to spend less effort winning work, especially with this tool chain idea that I just demonstrated using the favorite existing tools you know already. And then the ability to retain new talent and attract new talent because you're using best-in-class workflows and best-in-class tools. So with that, I'll just say I really appreciate the time to present to you. Since we just announced Rhino, we're putting together a kind of tiger team, early adopter, pioneer set of customers to test out our Rhino stuff. If you're interested in that, please reach out to me or reach out to someone at our company, and we'll be happy to give you the details. Thanks.
Wonderful. Thank you so much, Marty. So our audience will